Hello, we're going to use Fusion360 today to go over how to do toolpaths, generate toolpaths, and spit out G-code for our 2-op mills. The same process can be used for other mills on campus. You just need to do a couple different things. You have to know what the capabilities of the machines are, and you have to know what type of machine it is so you can post it properly. The piece we're using today is actually a piece that SEDS, it's our club on campus for the Students for the Exploration and Development of Space, want to cut out on our machine. The machine we're going to be focusing on today is the Southwest Industries Track 2-op. It's a small full 3-axis CNC mill, fully enclosed with flood coolant. And just for reference, the size of this part is it's a 1U CubeSat frame, so this is about 10 centimeters by 10 centimeters. Most of the dimensions in this part are in millimeters, so if we measured things from here, to here, you can see that it comes out to an ugly inch unit, but a nice millimeter unit. However, when you look at features that are common to machining or even hole sizes, so the diameter of this hole, the diameter is 3 point some gross millimeter, but it's a nice 0.12 inch hole, which is a standard hole size. There's going to be a drill bit specifically for that size. We don't need to ream it. And then if you look at internal features like this radius here, not the measurement between those, the radius here, this radius is, or usually the diameter is 1/8 of an inch or 3.175 millimeters. So thank you, NASA, for being a US company and being mixed between inch and metric units. Because of all the tooling that we have is in inch units, we are going to do all of the machining in inches. So I might refer to millimeters, but everything we're going to do is going to be basically, fraction of an inch. So 1/16, 1/8, half, things like that. Okay, so we've got our part here. This is going to be 6061 T6 aluminum or some other aluminum alloy that is applicable for space. And you'll just need to know basically your materials, your size, and things like that. When we go to machine, we're going to look at how many faces have features. Unfortunately, on this, all 6, you could think of it as, a sort of a cube. All 6 faces have features on them. That is usually the worst possible way to design a part, but sometimes it's unavoidable, right? You can see on the sides here, the only features that we need to go in on these sides are holes, and they all look like they have the same hole spacing. So those we can take care of later. So for this machining, we're going to focus on just doing basically, I don't know which is the top and which is the bottom, honestly. I think this is the top of the frame and this is the bottom. I guess it depends on which way you're looking at it because the pieces go on both the top and the bottom of the CubeSat. But for today, we'll be just looking at this side and then this side. When you start machining stuff, you have to figure out how you're going to hold it into the machine. So our machines all have 6-inch vices, which means they can hold a part up to 6 inches. Like I said, this is 10 centimeters, so 10 centimeters is less than 6 inches, so we're good. You're going to start off with stock material. We'll go into that in a bit. And then you're going to want to figure out which way you want to do first. When we go to clamp it in, it's really nice to be able to clamp on the sides of parts. Imagine this a big block of aluminum right now. Once I machine either these little features out or these features, I'm going to then need to flip it over and clamp onto something. These have a little bit more meat to them, and you can see that they the way they stick out, you'll be able to sort of clamp. You'll be able to put some sort of fixture inside of this here nicely that kind of retains in there nicely to then flip it over and do this. If we were to do this side first, these parts are so little, clamping onto them, even with a fixture, worries me a little bit that we might damage them. So we are going to be doing this top. This is the part I'm going to show you how to do, and then I'll leave the underside basically as an exercise, or I'll sort of explain how you would do this. So we'll start here. Okay. First step is Going to setups. First, make sure you're in the manufacturing mode here. So you have design, you have all these different options. Make sure you manufacture. We're going to right click on setup, do new setup, since we have no setups. It's going to try and guess what size stock material you need. That's what that yellow box is, and it's going to give you a coordinate system. Most of the times, you're going to have a different coordinate system for designing your part as you are for manufacturing your part. It's just, you have different needs. A lot of times, I know when I'm designing things, I do like to have at least one plane going through the middle of the part where I know there's symmetry. It just makes your life easier to have a nice central plane that you know how to mirror across. And then, sometimes maybe your top plane is a certain way or you're viewing it, but it's usually never the same. So what I'm going to do here, the machine we don't care about, we don't need to select anything there. Operation is usually default to milling. You can do turning, cutting I think is for like plasma cutting and stuff, and then additive is G-code generation for like 3D printing and stuff. But we're going to do milling, and then the work coordinate system. So we don't care, we don't want the model orientation. You can pick any of these. I just picked the first one because it's easy. It's going to tell you what do you want for your z-axis. In a milling machine, your z-axis is always the axis of the tool. So z-axis in this case is going to be up because we have a vertical milling machine. And then our x and our y are going to be sort of that flat plane that we create here. So our x is going to be left to right, and our y is going to be forward and back. So we'll select our z-axis. It's going to be this green one here, which actually says z. I don't actually want the z-axis going into the part. I want it facing up. So I'm going to flip the z-axis. And then my x-axis, I want, like I said, I want it going left and right. So you could pick either of those really. Because the screen just happens to be oriented this way, I'm just going to pick this one as my x. That's great. I do not want my axis though down here in the bottom middle of my part. My axes are pointing in the way I want. So I'm just going to go over here, click this thing that says stock point box. These little buttons come up again, and I'm going to pick this corner. You can pick any corner that you want. You can even pick the center, top center if you want. It's just going to make your life easier to pick certain corners. If you're going to do conversational handwritten G-code, this corner is nice because then all of your coordinates are positive. I really like this for this specific machine. I like this corner as my XY 0 just because there's going to be a rigid, when you clamp this into the vise, one jaw moves and one jaw stays rigid. So this is going to be the rigid jaw, the one up here. There's also a fixture plate bolted down to the plates we have here, and on that fixture plate has a magnetic stop that you can use. So if you're going to make 4 or 5 of these in a row, you can just line it up to these two surfaces basically, and you don't have to re-edge find between each part. You can just slap them in and you're good to go. And then your Z should be on top, especially for this first half, because it's easier. And you have a lot fewer risks of crashing the tool into the thing. So I'm happy with my coordinate system, but I don't really like the stock material. The stock material just does a relative size. It's going to pick a random size for you. So like my stock now is 4.017 by 4.017 by 0.630. You can't buy stock in that. If you go to McMaster and just look, you're not going to get this size stock. You're going to have to cut it to this size, and it's going to be a pain. So how about we just do a fixed size box, and we pick normal, even units. So now this tells us our model dimensions. So we just need to make sure our stock is bigger than this. I don't need to be an inch. It's rounding up to the nearest half inch. So I'm going to go 3/4 of an inch. We're just going to be wasting a lot less material that way. We could probably do 5/8. Yeah, we could get away with 5/8, but it depends on how easy it is to find the material. If you can find 5/8 material instead of 3/4, you'll save yourself a little bit of money on stuff that's just going to be turned into chips. So we've got that, and then it gives us 4 inch by 4 inch. You could bump this up a little bit. The your X, you can definitely keep at 4" because that's going to be, you can basically use that as whatever your stock size is if you buy 4" stock. But then the length, you're going to be cutting that off on like a bandsaw or something. You could give yourself a little extra leeway if you're worried about, you know, hitting these dimensions. You can make your width like 4.25 or like give yourself like 4 1/8 or something like that. We'll keep it like this for now. Hit OK. So we've got all this set up, and notice how it gave us a little bit of material on both the top and bottom. That's so we can clean things up, make it look good. We're good there, and the first step is we need to clear out a bunch of material. So that's basically your first step, is to core out where you see all of this yellow. We need to take out all of that, and we want to do that with the biggest tool that we have that's reasonable. Like I said, this is a relatively small part, and we have a bunch of different tools. I'll show you all our tools here. This is our tool list. This is basically our inventory of what we have in the cabinet in the CNC shop. So we can go down here, we can see all of our mill tooling, are these rows. And for roughing, we've got up to a 1/2" end mill. 1/2" is currently, we have a few specialty end mills that are bigger, but 1/2" roughing is totally fine. I think we can only fit up to a 5/8 in this machine anyways, or at least a 5" shank tool. So we'll go with a 1/2" roughing profile. You can look up this tool. I can tell you more about the tool later, but basically it's got a roughing profile which kind of has these scalloped edges, and it has 3 flutes. So we'll bring that back over here. We'll go in here, and we're just going to do adaptive clearing. Adaptive clearing is the easiest way just to get rid of basically doing your first pass. So I'm going to click on that. I'm going to select my tool, so it brings up this little window over here. I'm going to select. I have no tools in my tool thing. I also don't have nothing in my library. I think the library saves to computer, not to the network. Like everything else on Fusion360 saves to the cloud, but this doesn't. But they have all these samples in here. So I'm going to go to Sample Tools Inch, and you can see tons and tons of tools. I'm going to basically go down here and do a flat end mill. And then I'm going to pick a 1/2". Where's a 1/2"? 1/2" is right there. And then I'll just click on this roughing one. We're going to have to change this. Things are a little weird here. It might be a little bit too aggressive, but not too bad. So we'll pick roughing, hit select. I can't change it there, but now that I've selected my own tool, I can go back and change the parameters. So I'm going to hit select again. And now that it's up here, and this is a new tool library, it basically copied that old one. I'm going to go to roughing here, and then I'm going to hit edit. This little pencil thing. Do cutter, make sure it has the right number of flutes because that's going to affect the calculations. It has 3 flutes. All this other stuff matters, but only a little bit. Mostly just matters for checking for collisions and stuff, but these are all the same. It's a 1" cutter. Shaft, we don't care about. Holder, we don't really care about. If you had deep parts, I could give you the dimensions. I actually have created a holder that is the holder that we have dimensionally. Cutting data. So this is the one that we care about. So this number here, this feed per tooth, this is the one that's usually given by manufacturers. I can pull up that window too of a general guide. This is just a generic tool manufacturer. This isn't the tools we have, but they have these nice charts to show different materials, and then the chip load. So the chip load is this number that here, it's basically, you know, feed per tooth, so it's inch per tooth. We have a 1/2" cutter, and we're cutting aluminum. 6061 T6 is this sort of line here. 1/2" chip load per tooth with a 1/2" cutter says 4 thousandths. If you can see by default, Fusion360 is a little bit more aggressive. They think you can do 55 or 5.5 thousandths. But I'm just going to change this to 4 so you don't have to do any of the math. Again, it's nice if I change this to 4. Note how this cutting feed rate reduced a lot. But also notice how these lead in and lead outs and ramp didn't change. We're going to want to change those. So I'm just going to write 90 here, 90, and then 90. So we're matching up. I don't need to write 91.637, whatever. And then this plunge feed rate, we're probably not going to be plunging. You shouldn't be plunging. You should probably always try to like do some sort of lead in, lead out, or some sort of helical or zigzag ramp, some way. I'm going to change this also to 4. And that should change that. That should slow it down. We're not going to plunge, but once we've saved these parameters now, we now kind of have our own tool. So now see how it's changed here? For some reason it changed in slotting instead of roughing, even though I had roughing selected. That's okay, we can use this one. These are just, recommendations. So I just have to remember I use this tool. I go here, and I hit select. And now it changes all of these. If for some reason you wanted different parameters for just this operation, you could change it in here. But if you're going to be cutting a lot of aluminum, if you're always going to be using the same material, change it in the actual tool itself. That way you don't forget to change things. We're going to go to geometry. Bounding box is fine. Your stock selection. What it is here, we don't actually have to select anything. It's just going to be smart and find all the features here. Heights. However, this we do want to change. We don't want to go all the way to the bottom, right? Because we have these features. We're going to be clamping onto this stock material, probably on like these faces here. So we don't want to cut into those. So we don't want the bottom height to be the model bottom. We want the bottom height to be the bottom to where we're cutting. So I'm going to, instead of saying model bottom, I'm going to do selection, select this face here. Right, because we basically want to machine up to there. I want to leave sort of the material between these faces just to give it a little bit of rigidity when we flip the part over, and so we don't have a big hole in there. Do that. All these other clearance heights are fine. I like to keep these on for safety, basically to make sure you're not crashing into things. Passes. The optimal load, for some reason, is red. The maximum load of the tool must not exceed 99% of the tool diameter. So we have a 1/2 inch tool and it's saying it's 0.5. So let's just change this. It could be related to the step over. You could put the step over size there. Step over is usually 70%. So if you wanted, you could do 70% here. So you could do 0.5 times 0.7 if you wanted something more specific, and it'll figure that out. The one thing we want to look over is the stock to leave. Because we're going to be having these big surfaces, the radial stock to leave, we're going to be using a much smaller tool to get into the cavities. I'm going to change this down to 0.010 of an inch. And then, so radial is going to be all the sides, and then axial, I'm going to change this to 0. We usually get a decent finish. If you needed a really nice finish on the floor of these surfaces, you could change this and you could go back and do those separately. But the tool we're using is fine for finishing the face here. It'll do a separate cut most likely for the depth. Axial stock leave, I'll do 0. So it goes right to these flat surfaces, but it's going to cut, it's going to leave a little bit on the sides of everything. Linking, I usually ignore, right? It tells you how it ramps in, all that. Unless we're doing something special, I usually just check these first few boxes. Hit OK. It's going to take a second. It's going to be doing some thinking, and then it's going to do our first pass, which is pretty amazing because that's getting rid of probably 90% of the material we want to get rid of or higher. You can see the color too. When you select, if you just select on the screen, it shows you just the model, but if you select on the operation, it gives you the tool paths, and it gives you sort of what the stock looks like. So you can see the green part's the stock, and then you can see the wireframe through it is the material. So you can see we left, if you look at it on the sides, if I give this the right view here, you can see it cut right to this floor. It didn't cut right to these floors. It may not have been able to do the calculation. That's okay, we can clean it up, but it did leave material on the walls too. You can sort of change these colors and everything like that if you want in the simulation tab. It's basically giving you the same view as the simulation, but it's not running through it. It's just showing you what the final product looks like. But that gets us pretty close. If we now want to take these faces off, we can do that. We can clean that up, and we can use this same tool here. So we'll just do face. We'll keep the same tool. It remembers the last tool you used, which is nice. Geometry, I'm just going to click this, 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 and this. Make sure you're selecting the right features. tool orientation, heights, heights, bottom height, model top, which is good for me. I could select the face too if I wasn't sure, like if for some reason that's why, but passes, we don't want to leave any stock, we're good. Tolerance, all that other stuff is good. So we just hit OK. And it'll basically just clean these up. It just does 2 little passes to get rid of that material there. Okay, so we're happy with that. Now we need to clean up the sides. Like I was saying, you can see how it left a bunch of material in the corner, and that's just because the radius of the tool. So like I was saying, the radius of the radius here is 1/16 of an inch, so we're going to want to use an 1/8 inch end mill to do that little cleanup. So I'm going to do, for any external features, I usually like to do a 2D contour. You really only need to do this 3-dimensional contour if you have like swooping, like weird shaped, like spherical or any sort of, organic shape. But 2D contours does these because these walls are nice and vertical. I do 2D contour. I'm going to change my tool. So I'm going to go select here. I'm going to go into my sample tools inch. Again, go here, flat end mills. I'm going to go 1/8 inch. I'm going to do finishing. And of course, 1/8 inch end mill for chip load. This is probably fine. We're only going to be taking off 10,000ths of material along the side. We can slow it down if we want, but for finishing, you don't actually see how the feed rate is actually higher for finishing. Some of that too is because if you have too low of a chip load, you get some chattering and you may actually end up with a bad surface finish. It can be counterintuitive where you think maybe if you spin it fast and go slow. The one thing we will have to change is the RPM here though. Our machine only goes up to 10,000 RPM, so this is going to get adjusted anyways. So I'll select this. And the same thing like we did before, now that I've selected it, I'm actually going to go back here, find my 1/8 inch tool. Again, I can select on finishing here, I guess edit preset, instead of editing the tool. Change my spindle speed, watch how this other stuff changes. If I change my spindle speed to 10,000, you see my cutting feed rate actually went down. A ramp spindle, change that to, okay. And we should be good. Hit accept. And yes, so you want to change it. Maybe it didn't actually reduce it. It may not have reduced it that much. But that's okay. Select that. It did change it here somewhat. We'll go to geometry. I'm going to select, so this is going to be a little weird. I'm going to select this top feature, even though we want to go to the bottom. I'm going to select this top feature just because this is the profile we want to trace. So I'm going to select that. I'm going to select that, select that, and select that. If I accidentally click a line there, if I unclick it, it's actually going to give me this pop-up to do different selection. I can just hit delete because you can do other different interesting, like add this to my chain or like close it or open it, but I'm just going to delete it there. And then these red arrows are basically saying whether you're cutting inside or outside of the part. So if you're doing that way or this way, this is basically which direction the tool's cutting in. I don't want to leave any material or rest, this stuff's all fine. Heights, this is where I want to change because right now it's just going to cut to this top plane, which we don't want. We want it to cut all the way down to there. So from selection, and then I'm going to again pick this face. So it goes down to that height. I don't want to go down to here because we actually have these features, it'll cut these off. We'll do these little corners different. Again, just make sure on finishing passes you're not actually leaving any stock. So that should be good. Hit OK. Let it generate. And now you can see it is cutting around here and getting right nice into that corner. And we're almost there. The last thing we want to do with an end mill is we want to do this final sort of external perimeter. So what I'm going to do is I'm going to basically do the same thing. And you can see how there are these sort of recessed features here. These are sort of stress relief marks. These are also 1/8 of an inch in diameter, I think. Correct. Yes. So we'll just keep this 1/8 inch tool in here and it'll find those. So we're going to do another 2D contour. And we're going to select this big chain. See how this chain goes all the way around the part? We'll select that. We should be good. The tool, again, we're using the 1/8 inch. This is where, because we have this, it might be tough getting through the material on this corner. It's not going to be super deep. It's probably going to be, what is that? It's like 60 thousandths. It might be fine. This would be where we would do a test and sort of play with the feed rates. We could adjust this feed rate down if it was too aggressive going around that corner. Geometry, this looks fine. Heights, because of where we picked that height, should be good. Selected contour, so it's going to be the contour that we selected. And again, pass, make sure it's not leaving any stock because this is a finished pass, and hit OK. And we've got that, and that looks pretty good. You know, it leaves these little corners here, but we don't care about that. That's just material we're going to throw away anyways. Again, I didn't do the inside. Like I said, I didn't go in here because I want to keep that for stiffness. And now the only thing we have left to do on this side is drill out these holes. So I'm going to go here, drill. I'm going to select my drill bit. I said it was a 0.12, so I'm going to go in here and do drill. Go to my sample tools and scroll down until you find the right size. These are all the standard size drill bits. If you don't use a standard size, you're going to have to ream it. But we have a 0.12 right here. It's a number 31 drill bit. And we're drilling aluminum. Select that. Everything here is good. Again, you see the coolant. Keep this on flood coolant because that's what the machines have. It should be on all of them. Select our holes. For our holes, I'm actually going to select this bottom where it tapers. If you just select this, it'll stop at here, but you actually need to account for the taper of the drill bit. So if you use Hole Wizard, whether in Fusion360 or SolidWorks, it'll add this taper for you. If you don't, if you just make like a blind flat hole, you're going to have to account for that for your depths. You'll have to do the math, or your hole will be a little shallower than you expect it to be. If it's a through hole, it doesn't matter. So we've got that. Heights. The heights should be good. This is where you would adjust for it. See how it's cutting all the way down to that taper. And then it says hole bottom. Cycle. This is the most important thing with drilling in Fusion360. By default, it does not do pecking for drilling. It just does a plunge and a rapid out, which is really good at breaking drill bits. I learned the hard way by breaking a bunch of drill bits when I forget to change this. So really what you want most of the time, what I find works well, it takes a little bit longer, but if you're ever concerned, always do this deep drilling full retract. This is probably the closest to a good normal peck drill. I go here. The pecking depth, I let it pick its own depth. I think it does calculations based off of the tool size, and hit OK. It's going to figure that out, and it's going to be done. And now we have holes that are drilled. So we can go through. One thing we should do, even though we've been looking at these all along, we can go here into simulate. We can hit play. It's kind of fast. You know, we're doing adaptive clearing. We can slow this down when we do like some of the other stuff, but as long as it looked fine, you know, you can watch it. It's fun. You can change your settings here if you don't like the color. If you don't like green, you can change your material. The stock material is just an aesthetic thing. It doesn't actually like mean you're cutting plastic. And you can see each operation kind of gets its own color. Watch fun. Make sure you're not crashing. This says we're crashing, so we can rewind. We can rewind it here, and wonder why it says we're crashing. It looks fine. Sometimes if the tool holder and stuff isn't set up right, it says it's crashing, but that looks like it's doing the right thing. So we're happy with that. So what we would do from here is we would go in, we would right click on the setup, and we would hit generate, because we have, generate we've already done. We do post process. The post here, choose from library. This is going to matter because if you don't pick the right one, the software on the machine might crash or it might do weird things. So we're going to scroll down to where it says Southwest. I'm sure that you could search, but I just find scrolling past Southwestern Industry. And we're going to use the ProtoTrack GCD. GCD is any general G code for the ProtoTracks. KMX is a special one. These don't use the KMX, use the generic for that. And then conversational, we didn't do conversational. I don't know what it would Fusion360 would do for that. Hit select, it'll save it right. On the 2-ops, it has to be a number. You have to give it a number. It can't have any letters in it. It won't recognize it. Save this, make a number. I don't know. You guys can write whatever number you want. 1001 gets used a lot, so maybe pick a more unique number. But I like to do a sequence. So if I did 1001, then when I flip it over, I would do 1002. And then for my side holes, I'd do 1003, just to keep it easy so you know the order of operations. Hit post. And then it'll save it to a generic folder. You can go and find that and save it onto a USB drive. One thing to note too that you should really do, they have sort of a sheet here, but it's kind of, I don't know if I like it because it takes up so much space, but when you come to the mill, you're going to want something similar to this. So we'll just, I guess it just saves, so it saves this on the clouds, but whatever. Save, and it'll basically give you all the tools you use. It gives you your setups and everything like that. You know, whatever. I think this is overkill to print out and everything. I would just have a list of all the tools, which tool spot they're in. It's really important to know tool 1, tool 2, and tool 3 because when you put it into the machine, these tools need to be in those spots on the machine. Our machines can only hold up to 8 tools, so try not to do things too crazy, right? Like this, we did all of this with just 3 different tools. You can probably, for this side, you can probably use all the same tools. You'll still do the face, you'll do the adaptive clearing, you'll do the contour. You'll have to add one tool, and I highly suggest adding it as tool 4 so you can just load them all in. You'll need a radius tool, so you can do this. So if I do a new setup, hit OK. I don't know if this is going to screw things up, but if I want to go here, so this is something nice. I couldn't find this feature exactly in SolidWorks, but if you do a 2D chamfer, it's it's a fillet, not a chamfer, but it's the same thing. Select, you can go in here, you can find your radius mill. This one we will need to actually get metric because that radius needs to be a 1 millimeter. We don't have one here, so you'll have to basically pick something close, select it, and then you'll have to change the diameter of it. You'll have to basically create your own, edit this tool, and create this to like call this a 1 millimeter radius. I think that's the size you needed. You'll have to double check. I guess I could measure that right there. Actually, cutter here. Number of flutes, you'll have to change that once we buy it. I think we purchased one. I just don't know where it is. But the diameter, if it's a 1 millimeter radius, it would be 2 millimeter diameter. Shaft diameter, this all matters. Make sure all of this matches what I guess this overall diameter. This you need to make sure you know. You need to make sure you come in here and actually do this right. All this 12,000 again. You'll have to change this to 10,000. We'll just pretend this is what our tool is. Hit accept. Yeah, whatever. Select that tool. Ooh, that's an extra. Yeah. Geometry. So now this is nice because you can select either this top, maybe it won't let you, but you can just select this. Is it not letting me select the chain? You might need to play around with this contour. With chamfers, I had no problems with it. Hit OK. Okay, there's something wrong with the tool. You'll have to set up the tool, but basically you can just select these edges and cut around it. Other than that, you're pretty much good to go. And then the first one, I definitely recommend cutting the first one in something softer like plastic or something. You can kind of just see how things work. And then you can cut all of them once you need it. Always plan to make more than you need. I know you need 2 of them. You should plan to make 4 to 5 of them. I know it's a lot of material, but you're going to screw one up. I've screwed plenty of parts up. Always plan, unless you're a professional machinist who's been doing it for like 20 or more years, you're not going to get it right on the first try. Okay.